Hey everyone, my name is Kunal. In this video, we're going to talk about Argo CD and how it works with Kubernetes clusters. So before we talk about Argo CD, we're going to talk about GitOps, what GitOps is. We're going to talk about that and how does the GitOps workflow work. And then we're going to talk about what Argo CD is. Like if we talk about Argo CD after talking about GitOps, it would make all the sense. And then we're going to have some sort of an Argo CD tutorial at the end. I'll set up the Argo CD on my Kubernetes cluster and access it and I'll deploy application. So what is GitOps? GitOps is essentially kind of applying the software development practicing to infrastructure automation. So what does it mean? Like, you have your infrastructure definition stored on GitHub repository so that you can revert or track the history whenever someone making the changes to your infrastructure. GitHub repositories act as a single source of truth. So if any changes are being made to your infrastructure, they should be reflected on your GitHub repositories or Bitbucket or wherever you're storing your repositories. So how does the GitOps workflow works? Like, you define your infrastructure, whatever, like in our case, we would have a Kubernetes manifest files, like, how we want to define the application, what sort of resources it should have on Kubernetes cluster, what kind of service that we want to create. And then if we want to make any sort of changes to our code that we had defined on GitHub, we will do it using pull request or merge request. And with the GitOps, there are tools like Argo CD, Flux CD that they will push your changes to Kubernetes. So imagine you have a service or a pod, you make some adjustment to on your GitHub repository, that request get merged successfully, and the tools like Argo CD will merge those changes to and reflect those changes on your Kubernetes cluster. So that's what I mean by automated reconciliation. So it also has this self-healing capability. So it means that if you make any sort of changes on your Kubernetes cluster or on your the destination, it would revert those changes and it would make sure that it matches with what's on your GitHub repository. We'll see that in an action when we do the tutorial. So now let's talk about Argo CD. So Argo CD is kind of like a GitOps tools for Kubernetes, and it ensures that whatever your desired state is defined on your GitHub repository or wherever your repository is stored, it matches with the live state on wherever it's getting deployed, which is Kubernetes. So it also provides real-time UI for your apps and give you get picture of what is deployed in your infrastructure, and also provide multiple sources to wherever you define your manifest. It could be just a YAML file stored on Git, it could be Helm or even customized. And you could deploy your manifest across multiple containers. You could be managing just one cluster or you could manage multiple clusters. So it has the ability to auto sync. You can roll back your changes. You can do your history tracking. It has a health status available, has a capability for single sign-on. If you using Google Workplace or Microsoft, anything like that, you would be able to integrate with Argo CD. And there is a CLI tool available as well if you want to automate some of the actions that Argo CD takes. So let's do the tutorial. So before we start the tutorial, I just want to quickly let you guys know that as I did for my other videos, that I prepared GitHub repository, and there is a directory on my repository and it details all the steps I'm about to take, and that's what I'm referencing to. So I just let's do a quick overview on what's in this repository. So the first, we will have a Terraform code that will create the EC2 instance for me, and then I will connect to that instance and I will configure the Docker on it. I will install the kind Kubernetes on it, and that's what we will use to install our cluster and connect to it. And after declaring everything or setting up the kind cluster, I will install Argo CD. Once Argo CD is set up, I'll deploy some sort of an application, the blog application you might have noticed that I've been using in my other videos. So we'll deploy that application to my cluster using Argo CD. I wouldn't be performing kubectl on my cluster, and I'll show you how you can deploy those apps using UI, or you could even do it declaratively. You can define how you want to deploy your app. The Argo CD allows you to define those steps in some sort of a YAML file, and then you just do the kubectl. So I just want to let you guys know that all the steps that I'm performing are some sort of documented on the repository. I'll leave the link below for you guys. If you just follow it as along with the steps, or as you're watching me, you'll have no trouble deploying the app that I'm about to deploy. So let's get started. So first thing we're gonna do, we're gonna create the EC2 instance and set up our cluster. I'm not gonna focus too much on it. I have other videos that covering how do you define the cluster, what are the things you're going to keep in mind. In this video, I'm just going to quickly set up my cluster. So first thing I'm going to do, I'm going to go to the Terraform directory, and I have as some resources that I'm creating EC2 instance. I'm creating a couple of security group as well, which is allowing the access to it. So let's just quickly create that. I'm just checking if there are errors to my code. It looks good, so I'm going to do Terraform apply now. Confirm. Like I was saying, it's not creating too many resources, it's only creating 2 resources. It's a EC2 instance and a security group. So it's going to utilize, I believe, the default VPC to create my resources in. So okay, so the resource has been created. It's going to output the IP address of the instance that is created, and I can SSH into it. There's a command available, so just make sure that you have some sort of a the PEM key available while you're creating this EC2 instance. That's not the IP I have. To set up a kind cluster, we're going to install Docker, so I'm going to quickly do that. So using yum, and I'm also going to change the modify the group. I'm going to add my current user to Docker group so that I won't have any permission related issues. So exit out of it and log back in. If I don't do that, the membership won't take in effect. So after doing that, if I run docker ps, that means my Docker is working and I don't have any trouble with the permission. So commands that are provided on GitHub, if you just run it as they are provided, you shouldn't have any trouble running Docker. So once the Docker is installed, I've prepared the script, which is again available on our GitHub, that's gonna set up the kind cluster. Let's just quickly take a look at it. So basically it's downloading the binaries, it's gonna install the kubectl, and then it's gonna set up the kind cluster. So let's just quickly download this one and run it. Once it's downloaded, we gotta change its permission so that it could run executable permission. So after doing that, run it as a sudo, and it will install kubectl, like I said, and set up the kind cluster. So it'll take about a minute or so. So our cluster is set up. So when it comes to kind, you typically use kind utility to interact with the cluster or whatever has set it up, but you can also use kubectl. I'm more familiar with the kubectl, so that's what I'm using. So after installing kind cluster, I should be able to run kubectl commands and see if the node's been created. Oh, there seems to be some sort of a trouble here. The issue I was seeing that I was unable to do kubectl because that I didn't install the kind cluster as regular user. I installed it as root and running the script as sudo, so I shouldn't be doing that. So what I've done that I've removed the cluster and I'm gonna reinstall it now. So I'll download the script again, and then we'll run the script. This time when I'm running it, I'm gonna make sure that I don't run it as sudo. So let's quickly do that, and once this is installed, I should be able to run kubectl command just fine. Okay, so our cluster has been installed. So if I do kubectl get nodes. It's gonna list that there is one node available. It's not ready. It should get ready within, like, I want to say maybe 20 seconds or 25 seconds. So you may have to wait around for that time. Okay, there it is. So it's ready now. So once I'm gonna clear this window. So now is the time to install Argo CD. So let's just quickly clear this one here. So I'm gonna go back to the README. And first thing what we're gonna do, we're gonna install the Argo CD namespace, and then we're gonna download the manifest that would install Argo CD. So this is, I'm picked this up from the official documentation. So you can just paste it, or you can check out the official documentation, how to set up or install Argo CD. So let's quickly do that. Let's go back to the terminal and create the namespace and install Argo CD. Now we're gonna list the pods that are running in Argo CD namespace. Okay, so all of our pods are running. One of them is ready, almost running, but not in a ready state. This is the main one. This is the server pod that we'll be interacting with. So we're gonna make sure it's running. So it is now. So let's just clear this window. So the next thing we're gonna do, we're gonna enable how we're gonna access the Argo CD server. It depends on multiple factors. If you wanna set up load balancers, we could do that, or you could use the node port, or you could also do the port forwarding using kubectl. So that's what I'm going to do. If you're interested in setting up load balancer so that you could use a particular domain to access Argo CD, leave a comment below and I'll make a video on that topic. So let's just use kubectl and we'll do the port forwarding. So what I'm doing here is that I'm just telling that I want to have this service, which is Argo CD server, sitting in Argo CD namespace, and any address could access it on port 880, which is essentially mapping it to 443, which is the Argo CD service port. And I'm just outputting whatever it's going to output to just nothing and running it in the background. So okay, so now I have a running job. So what I have to do, I have to grab my EC2 instance public IP address and access the Argo CD on the port 880. So I just grab the public IP address of my node, go to web browser, type port 880, and I should be able to access this some sort of a portal. So you might see a security warning. Click next on this one, and you're gonna prompt it for username and a password. So there's the secret created while we install Argo CD, and which contains the password for your Argo CD. So this is the Argo CD initial admin secret, which contains the password for admin users. So if I just run this one, this is gonna output the password. I can just grab this one. It'll probably different for you. It's not gonna be the same. So it get randomly generated whenever we install Argo CD. So I'm gonna provide that password. I should be able to access Argo CD UI now. If I want to change the password, I could come to user info and update the password. And after you do that, you can also delete the secret where we just access the password from, so that anybody else can just retrieve the admin password and accessing your Argo CD. So now we have Argo CD set up. So before we explore everything, whatever is here, let's just create the app and see its functionality basically. So we're gonna create new app and define what kind of app we're gonna create. So I'm gonna say blog app. There's a default project available. Projects are typically used to separate your apps, and the sync policy. So do you wanna have your application synced to your cluster automatically or manually? So I'm just gonna leave it manual for now. Ignore this options for now. I'm just gonna click on auto create. I'll be discussing what does each option mean. So Now we're going to provide where does our app live. So if I go to the repository directory that I'm referencing, this one, it has this manifest directory, and it contains the relatively simple code is doing a deployment. It has 2 replicas and defining the location, limiting the resources, using resources, and it has a service. So that we can access our app on a node port. So this is what it's going to reference to. If you have a private repository, you would have to provide the SSH credentials. I'll make a video on it separately. For this one, I have a public repository. I'm just going to provide the repository, and you can even, like, if you're just following along, you can just provide whatever's in the README, and you'll be able to deploy it. So just make sure it's Git, and what's the latest head. So I'm just gonna make sure the latest changes, and then it's asking for you to where does this application live. So you gotta define the path within the repository. So in our case, it's gonna be Argo CD manifest within the YT directory. So just paste that one here. And the destination. So in this case, we're just deploying the in server, like wherever the Argo CD installed, that's where we want to deploy the app. So for that, you just select the default service and the namespace, like where you want to deploy your app. So I'm just gonna call it maybe block app 01. And for the directory recursive, we'll be talking about it shortly after we're creating the app. This is not applicable, the app that we're creating. So let's just click create here. So if you look here now, after creating it, it's telling you it's out of sync. So what it means that this app isn't deployed to the server. So if I just do sync, and I have a bunch of options to select from. I can select or deselect what kind of app I want to deploy or the resources. So click synchronize. What's going to do, it's going to deploy to our cluster. So now you could even see it in the UI, like, while your apps are being deployed. And once everything is deployed, it'll tell you the sync is okay. So let's go to our cluster and see if it's if those pods being deployed. So I have to do get pods to all namespaces, and here they are. They've been created in the blog app namespace. The pod names are there. They were just created like literally 21 seconds ago. So there it is. So if I want to access this app, so I should be able to access it over the port 3001. So let's quickly do that. Okay, there it is. So I can access this app. Just keep in mind that when we created this instance, the security group that we attached, we allowed this particular port to be accessed. And I also, when I created a kind cluster, I also mapped the porting. So that's why we're able to access this port. So just in case if you end up using different port and you can't access it, just make sure the security group allows it. And if you're using kind, then it's also mapped to your kind cluster. So, okay, so that's pretty neat. You can create it on a UI, but when you're in a production environment or when you're working for a company or anything like that, you don't want to create application on UI, which, anybody could create and delete, and you wouldn't have any, some sort of a, way to roll back or track. So typically, in companies, what people do, they create whatever we just did on UI in some sort of a call it Argo CD application, so that you could deploy your apps declaratively, and you have some sort of a you keep a track of what is on the Argo CD. So for that, I've prepared this application. It's sitting in Argo CD App directory. So with this app, so we're defining the API version, and the kind is going to be application. For the metadata, we're just providing the namespace. So the namespace, you got to provide Argo CD. You can't provide different namespace. So this is for where we want to have the application should need it. So always provide Argo CD or wherever the Argo CD is deployed. So the specs is the place where you would have defined where your repository is. So you have project, you're going to pick the default. If you're not, if you don't provide something that isn't created, it will error out. So, and then you provide the source where it is, and then the target revision and the path where that particular app is. So I probably should update this path. So this isn't the correct one. Let's quickly update this one. I typically would do PRs and stuff, but this time I'm just doing it on fly. So just make some changes here. And okay, so this is where our app is located on this repository, and the destination, so we're providing is going to be the wherever the Argo CD is deployed, and the namespace for it, so the block app. And when it comes to sync policy, we're just making sure that if the new namespace is required, create one. So okay, so this is our application. Let's create this one now. So to create this one, you just do kubectl on your cluster and reference to your application file. So what I'm doing here is just referencing to this Argo CD app that's sitting on my repository and doing the kubectl apply. So once I do that, and I could go back to my Argo CD, and you see that there is this blog app popping up, and there is apparently an issue. What's going on? So it's saying path does not exist. So, okay, so I had to do a bit of a troubleshooting while trying to create the Argo CD app using declaratively referencing to this YAML file. You probably noticed a couple of commits on my GitHub repository. I had the repo URL provided incorrectly, and the path wasn't specified correctly as well. So this is the Argo CD app we have defined declaratively. So I'm gonna reference to this file and create the application on our cluster. So I'll have to do kubectl and reference to this file. So what it's going to do, it's gonna create a application on Argo CD, so you can see that application on your UI. So once this is there, so you could just enable the sync, and this will deploy your application to your Kubernetes cluster. So once it's deployed, you should be able to just do kubectl get pods in your namespace, and it should get listed there. So there they are. So they've been created like 10 seconds ago. So there it is. So you could create your apps in a UI or in a web UI, or you can create it declaratively. So now let's explore this the UI. So you can even list the apps which are synced and that are out of sync. There are there's that bit you can filter your apps based on the status, if they're healthy or suspended, and you could kind of check their status and then kind of take action accordingly. You could also filter based on the labels and the projects and even the different clusters. So I'll be making a video on how you could add multiple clusters to your Argo CD. But for now, there's only one cluster, which is the default one, and the namespace to wherever your applications are deployed. So let's go to the app and look into its some sort of a sync option. So let's quickly go back to new app. And when it comes to sync options, first you have skip schema validation. So if you're creating some sort of a custom applications and you don't want to have your manifest YAML to be validated, you could select this one. If you could auto create is basically if the namespace doesn't exist in your cluster, you could create it. When it comes to prune loss, it basically makes that all resources that are marked for deletion deleted only after the related resources are synchronized. In case in a service or deployment scenario, the service will remain active until the new deployment is fully synchronized or applied. When it comes to auto apply out of sync only, it only updates the resources that are out of sync. If your application isn't ready sync, but you don't want Argo CD to reapply all the resources, you can choose this option. You may have multiple resources and you only want to apply certain resources again, but not everything, whatever is within the applications. So respect ignore differences. So basically it ignores particular options within your manifest so that it doesn't detect as a changes. Server side basically means that it only uses server side for patching instead of client side. It resolves the merge conflict for the complex resources. Like, you could have a multiple controller modifying the same resource, like, Kubernetes operator, Helm, and Argo CD, but you can apply this option so that it only uses server side apply. And then you have a prone propagation policy. So basically how the resources get deleted. So when it comes to foreground, it makes sure to block the deletion of the parent resources, and it makes sure that all the dependent resources are deleted before the parent resources are deleted. And essentially, if you select background, it goes other way around. And for the orphan, is basically delete only specific resources and doesn't bother with the dependent resources. When it comes to replace, it's basically that it will recreate the resources whenever you're applying that, if they exist. And it tells you, like, the retry, like, how often do you want to retry it, and the limits for retrying. When it comes to directory, it's basically you could have a manifest sitting nested within the directory. So, you could treat your repository as a main directory, and you could use a recursive lookup within the main directory. And you could also provide this a top level argument to provide arguments to if you are using Helm. External variables would show any sort of external variables if they are applicable. So when it comes to include, you could specify which files that Argo CD should include, and exclude is basically what files you want to have it excluded. So if I cancel this one, so for now, what I'm going to do for this app, I'm going to enable the auto sync on this one. So if I come to my application details, I could enable auto sync. So what it means that any changes I would make to my repository, they will get automatically deployed to my cluster. So right now I have an app which has couple of pods and and a service. So let's make some changes to our manifest file. So if I go to my repository and go to manifest, and I'm gonna update these replicas to 5. So if I do that, make the commit, merge the changes, this application, you'll notice very soon that it's gonna start working and it's syncing and it's creating those pods in my environment. I didn't have to do anything. I made the changes on my GitHub repository, and it's deploying those changes to my Kubernetes cluster. If I go to my cluster and run kubectl pods on all namespaces, you would see that some of the pods are being created and they are in a running state. So Argo CD did that deployment for me. It only happened because that I enabled the sync automatic. Otherwise, if I had it manual, I would have to come into portal or any sort of other ways using Argo CD CLI, using some sort of automation. I would have to improve it and they would get deployed to the cluster. So when it comes to details for our application, you could also view the manifest for your application, how they are creating. You could also view the events, when those events happened. When it comes to each elements that we are deploying, we could also view the details and events related to it. You don't have to go to Kubernetes cluster to kind of check why is it happening. And this is where the drift will get detected. It will see if we're making any sort of changes. You will see them here that this is what's been changed. If I come back here, let's quickly refresh this one. So it's still in the progress state. One of the app is being deployed is in the error state. So now I'm getting, it's a good thing it's happened. So like I don't have to go to my portal to the cluster. It's saying that I don't have enough CPU available because I limiting my pods to consume particular amount of CPU and memory, and I'm running my cluster on relatively small node type, which is T2 medium, and has limited amount of CPU and memory available. So I'm getting the error that it can't be deployed. So you could check those events on your UI, and you don't even have to, I don't even have to go to my portal. So I'm at a cluster to see what's happening. So it's telling me why isn't working. The events are available for each resource that we're creating. So if I come here, you could view its event, like a particular pod, I go into it. I could also view the logs of the container, so how it's booting up and everything, and I could get a bit information about my application. So yeah, so this is all I want to show you guys, introduce you guys how Argo CD works and how you deploy it. And in the next videos, I'll be exploring how you could access your private repository and what you need to configure to access those private repository. I'll also be exploring how you could deploy your application across different clusters, so how you set up Argo CD for that. So stay tuned for that one. Thanks for watching. If you find it informative, please consider liking and subscribing to my channel, and thank you.